friends, we'll solve problem on kinematics of rigid body. Let's see what is given in this problem. At the position shown in figure, the crank AB has angular velocity of 3 radians per second clockwise. Find the velocity of slider C and the point D at the instant shown. Length AB equal to 100 millimeter. Now figure is given in this problem. Let's see figure what is given. First, crank AB rotates about point A, which is supported at A. That means it is a hinge support. That means a link AB performs pure rotational motion about point A. For link CD, we have to represent, we have to find out position of ICR. Now as AB performs pure rotational motion and omega is given in clockwise direction, linear velocity of point B, if you want to find out, it is perpendicular to radius of rotation, that means perpendicular to AB, and clockwise direction omega, that means linear velocity of point B must be downward. So this one is VB. As point B moves in downward direction, which one is a common point on link CD? This slider C has to slide in horizontal direction. So it moves in rightward or leftward direction, depends on B moves in which direction. As B moves in downward direction, this point C has to slide in rightward direction. So what will get here? VC. Now you know linear velocity of 2 points, that means point B and point C on a rigid body. Therefore, ICR, if you want to represent, will draw perpendiculars to VB and perpendicular to VC. Perpendicular to VB, if we draw, what will get here? Horizontal line. Perpendicular to VC, if we draw, what will get here? A vertical line. This is perpendicular to VC. That means this one is perpendicular here 90 degree. This one is again perpendicular here. Point of intersection represents ICR. As we are getting ICR for link CD, linear velocity of this point D is perpendicular to radius of rotation. For point D, radius of rotation is line ID joining point D to center of rotation. That means if I'll represent here now radius of rotation as ID, so this one point D I'll join here to this point I, so that radius of rotation is ID. From direction of VB and VC, easily we will get direction of omega, where about point I, this triangular plate say rotates about I, VB downward, VC rightward. That means omega of this link will get in anti-clockwise direction. This is omega CD. From this one, linear velocity of point D must be perpendicular to radius of rotation. That means perpendicular to ID. Therefore, if we will represent here a line which is perpendicular to ID, we will get linear velocity of point D like this, which is perpendicular to ID. Now, if we will find out some inclination, because direction of VD is very important. If I'll assume this VD is inclined at some angle, maybe beta with vertical, that means as this, if we construct this triangle with vertical angle is beta, so with horizontal what angle will get? 90 minus beta. That means with horizontal this line definitely inclined at an angle of beta with horizontal. From these triangles we have to find out length IB, then length IC and length ID. In addition to that, we'll find out angle beta, where one more length is given in problem, where vertical distance between this slider and this hinge at A, this distance is given as 100 millimeters. As this distance is given, vertical dimension here 100, length of this link BC is 125. From this one we'll find out this length IB, length IC. For that one, if we'll assume this angle as beta, here also some inclination will get, because You know this vertical dimension as well as horizontal dimension will find out applying Pythagoras theorem. Therefore, next step is to find out length IB, length IC, length ID and angle beta. Therefore, now to find out this angle, if I'll assume say this angle is theta and this angle I will represent here as angle again theta. Is it possible to angle theta from triangle IBC? It's easy to find out. From this triangle IBC in triangle IBC, IC length is known. IC equal to given as 100 mm. Then BC length is known as 125 mm. Therefore, length IB, applying Pythagoras theorem, will get this length IB equal to BC square minus IC square. Length BC is equal to 125 its square minus this one is 100 square. Therefore, length IB comes out to be 75 mm. Once you will get length IB, now inclination of that inclined bar CD with horizontal, that angle theta, if we'll find out, if we'll use a tan of this angle theta, which is opposite upon adjacent, opposite is IC, adjacent is IB. You know IC length is 100, IB length is 75. That means angle theta is tan inverse of 4 by 3. That means we will get this angle as 53.13 degrees. Just see figure, angle theta you are getting 53.13. That means this angle you have calculated. Now this is 53.13. As this angle is known, what about this angle? Easily you will get this angle 180 minus 53.13. If we will find out, we will get this angle as what? 180 minus 53.13. 180 minus 50 is 130. That means it is 126.87. Now how will find out other length? IB you know, IC you know, right? Now IB length is known, BD length is 125. That means length ID is possible applying cosine rule in triangle IBD. Because angle between IB and BD is known, therefore cosine rule if we apply, ID will get, and then applying sine rule will find out angle beta. In triangle IBD, will use here cosine rule. Now using cosine rule, what will get here? Length ID is possible. ID equal to square root of IB square plus other length what is known is BD minus 2 times IB into BD into what angle you have calculated between the two lines is 126.87. IB length you know, BD length you know. Therefore, from this one, if you find out this length ID, substituting values of IB, BD, this length comes out to be 180.28 millimeters. Once you will get length ID, next step is to find out inclination beta. To find out angle beta in same triangle, if you will use sine rule, using sine rule, this ID length you know, therefore this ID length divided by sine of opposite angle is 126.87 and length BD, which one is known, that is 125 mm, divided by sine of what angle we have to find out is angle beta. Length ID is known, therefore angle beta is easily possible. This angle comes out to be 33.69 degrees. Now to find out all linear as well as angular velocities, all lengths are ready. After angle beta, now we'll find out all linear velocities and angular velocities, applying our equation V equal to R omega for links AB and for link CD. For link AB, omega is known, therefore VB, if you want to find out its distance from center of rotation. Distance of point B from center of rotation is AB into omega of this bar AB. Length AB is given as 100 mm, therefore this is 100, and omega is what, 3, therefore VB is 300 millimeters per second. Once we'll get this velocity, then we'll select the next link, that is for link now CD. As B is a common point for this link, again VB if we'll write, then this equation becomes IB into omega of link CD. VB is 300 equal to IB length you have calculated, it is 75 mm into omega CD, therefore omega CD comes out to be 4 radians per second, and direction already represented, it is anti-clockwise from figure. Once we will get omega CD, now VC if you want to find out, it is again distance of point C from center of rotation, IC into omega CD. IC length is 100 mm. If we substitute in meters, so it is 0.1 into 4. So what VC will get is 0.4 meters per second, and direction of this velocity of slider is rightward. VD, if you want to find out, it is ID into omega CD. Length ID you have calculated, it is 180 point something mm, therefore in meters if we'll write, it is 0.18 into 4. What linear velocity will get is 0.72 meters per second. And with vertical, this angle you have calculated as angle beta, which one is 33.69 degree. What is asking problem? Omega of link CD, linear velocity of slider C, and linear velocity of end D. Thank you.